afternoon. My name is Paulo Drius from Federal University of Rio Grande in Brazil. And today I will present the paper, a comparative study on sigma point common filters for trajectory estimation of hybrid aerial aquatic varicles. So the motivation for this kind of hybrid varicles is the exploration or inspection in partially submerged environments. For example, you have like roofs, rainforest, but also oil platforms and ships. This varicle called AGU-AUVs. The design of this varicle is a challenge since the complexity to transit the medium between mediums. Besides this structure design and hardware layout, the navigation, tracking, and sensor are also a challenge. This paper talks about tracking. The AGU-IV high drone was published in IROS 2014. The patent was published in 2013, and the control system in ICRA 2015. Initially, you proposed a conceptual model, but today you have both a physical simulation, but also a prototype that is on evaluation. In order to track the trajectory for this kind of varicle, you have many different challenges. You can list the time variance disturbance in the case of winds or water currents. You have the communication delays, you have noise, and unavailability of sensors. For example, GPS are not available during the underwater phase. You have limitation on light propagation in order to communicate using Wi-Fi. You have ground effects in takeoff. You have body rigidity, and among other problems that you have. So in this paper, we evaluated you choose three different common filters based on local non-linear derivative free. You evaluated the unsated common filter, the curvature common filter, but also the transformed unsated common filter. There are many works showing the worst performance of the extended common filter compared with the UKF, so we just evaluated these three common filters. The results shows that the curvature common filters is slightly better than the TUKF, and both are better than unsated common filter. So, thank you by your attention, and for more details, I will be on the stand 6.